Hello, my name is Katia Yanis, future space geologist. Today I will be presenting information about the first Martian year results for the InSight lander. Here is just some introductory information regarding the InSight lander. InSight is an acronym, as many of the landers and rovers are. The one name here that was new to me is geodesy. Geodesy is basically an earth science that it focused on accurately measuring the planet's geometry and its orientation in space. This is used in order to understand what the interior composition of the planet is, and I'll be talking a little bit more about that in the following slides. The first thing to understand here is that this report is based on a Martian year and not an Earth year, which is not the same. The term sol there is basically to represent a Martian day, which is a bit longer than an Earth day. Here are the scientific goals for this lander. The first, we're trying to understand the formation and evolution of Mars, which is something we can do by learning about the interior structure of the planet. And then the second goal is to try to determine the level of tectonic activity that the Mars is still experiencing. These are the instruments. For this presentation, I'll be focusing on the first instrument, which is SEIS, I believe it's pronounced. It is basically a seismometer that is studying the waves created by any Marsquakes. The second one is it's called the HP3, and it's basically a heat probe or a thermometer. It was meant to be buried deep underground, about 5 meters, but there were a lot of issues trying to get that accomplished. At some point, the arm had to help the mole, as it's called, to bury itself. So it is completely underground, but it's only a few centimeters, which is not what was originally ambitioned to do. The last instrument is called RICE, and this one is basically tracking the wobble of the Mars North Pole. This is being done by using radio waves, and it's basically trying to determine what the Mars core is like. We saw a video, I believe, from this class in one of the lectures that was about an astronaut rotating a hard-boiled egg versus an egg that had a liquid interior. The rotation is different, or the form, the way it wobbles is different depending on whether it's solid or liquid inside. So that's basically the same thing they're testing for here. Here are the 4 papers that I will be referring to. Citations as well as the links to the PDF files will be available in the last slide of this presentation as well. I've selected these 4 because I will be focusing on the seismometer instrument SEIS. Because of time limitations, I'll only focus on that one. This is the first paper we'll be talking about. It's referring to seismic noise. Seismic noise is basically a generic name for a relative persistent vibration of the ground due to like a multitude of causes. There was a window of low noise at the beginning of the data, but the low noise window was lost after about Sol 500 because there was a pickup in the atmospheric activity. There's a very complex structure to this noise. There's a wind that is moving the lander. There's also some thermal ground deformations, and also the way the seismometer is placed in the ground is also not perfect fit, so there is some issues with that. So there's more analysis that is needed in order to determine of the activity captured by the lander, whether it is background noise or seismic wave. Here is the seismic activity recorded It's about short of 1,300 events. The activity is intermediate between moon and interplate Earth. Interplate refers to all those earthquakes that occur in the interior of a tectonic plate rather than at its boundaries. So this is a preliminary answer to that second science goal of determining the level of activity in Mars. Of course, it's not conclusive yet because there is a lot of seismic noise, the issue that we mentioned earlier. This feature in Mars that is picture on the right is the Cerberus fossae. And a lot of the events happen or were clustered near these particular feature, I put the picture there of the three-headed dog. This is actually from the Greek mythology. It's also known as the Hound of Hades. That's what Cerberus is. And I put this here. Hopefully, it will help everyone remember the name because this feature just became really important. The seismic clusters there are strong evidence that this is a fault system. And then the other thing that this paper mentioned is the extended mission. In order to get this mission extended, it's important to have its primary goal to reduce the background noise so we can distinguish the signals that are being received by this lander. This is the second paper. This team is using the seismic data to try to determine the composition and information about the core. The image here is it's what it was thought of before InSight. You see right there, it says it's where it says core, whether it's solid or liquid, it was not determined. It is now believed that it's liquid, and that it is larger or in the larger range that it was previously determined. Even more interesting is its density. For comparison, I have included the Earth's data here, but the density of the core of Mars is estimated to be about half of that of Earth. And what that means is that the composition of the core must include some lighter elements in addition to the iron and nickel that we find on Earth. There is possible sulfur, silicon, carbon, oxygen, and even hydrogen. So these large core also means that it is unlikely that there is a lower mantle. This particular composition, the team is looking into some experiments in the laboratory where they can put these elements together and put them under high pressure and high temperature to see how they behave so we can better understand this type of core. This is the third paper. The seismic activity seems to have some seasonality aspect. Note here that only 118 events were analyzed in an attempt to remove all those events that may be seismic noise. These are the possibilities the team here is mentioning for the seasonality of these Marsquakes. The first one would be potentially meteorite impacts on the surface of Mars. This is believed just because the impacts might occur more frequently when Mars is at aphelion. Aphelion is the point in the orbit where Mars is farthest from the sun. However, no impacts have been observed, and we have no way to indicate that any of these events are actual impacts. Another idea could be solar tides. However, there is no accessible data because there is a lot of wind during the day. Also CO2 ice loads, either from evaporation or deposition. These events are recorded on Earth. It's called the reservoirs do cause seismicity on Earth. So this is a possibility. The other possibility is illumination, and this has to do with the sun hitting sides of craters or sides of mountains and causing landslides. However, landslides tend to be not very efficient at creating a seismic source or a seismic noise. So it is possible but unknown. The only thing that was being able to ruled out is Phobos tide because there is no peak of these events during the period orbits of Phobos. I quoted verbatim here what they said about this unexpected seasonality of Marsquakes because I thought it was very well written. That is basically a doorway to new science. There is a phenomenon here we just don't understand and it needs further investigation. This is the last paper I chose. This team is attempting to map the structure of Mars mantle. Note here that only 6 events were used, again, due to seismic noise. Due to the small amount of the data, there was a lot of very complicated math and statistics that had to be used. It's a bit beyond my pay grade, but the information will be in the link at the end if you want to know more about how they were able to make any decisions based on these small amount of data. Now, one of the complications to try to map the interior of Mars is that we don't have epicentral distances, because that usually requires, or not usually, that does require more than one seismometer. And this picture on the top right represents 3 seismometers on Earth and how they triangulate to find an epicenter. So since we only have InSight, this is very difficult to do. Another complication would be the crustal dichotomy between the north and south hemispheres of Mars. As you see on the bottom right, there is the topography of Mars, and we can see how both sides of these planets are very, very different. Here's the conclusion. It's basically all the talking points that I've gone through. This is how science works. We look for answers, and sometimes we find more questions, which is just as great. This really means that we're broadening our field of knowledge of what Mars is like. I will leave you with this wonderful quote by Carl Sagan. Somewhere, something incredible is waiting to be known. For me, that somewhere is Mars, and that something is geology, and I hope everyone can find something to be just as passionate about. As promised, here are the works cited. I hope you really learned something new and you enjoyed this presentation. Thank you very much.